evaporative system monitor test. You're in the right spot. So, of course, if the monitor runs to complete, or the test runs to completion, the monitor is going to show as either complete or incomplete, but not all years will show you pass or fail, on the Subaru, that is. But I want to say, though, before continuing, well, here, go ahead and read it. But the next part here is not for the faint of heart, because, of course, now we're headed to the Eurozone. The readiness monitor generation. If there was ever a time that you thought to yourself the service information for Euro vehicles was meager at best, they offer a ton of information. It is a matter of where you find that information. Again, I'm going to do that plug again. We are here to help you with that. Yeah, just contact us. If you're a customer of ours, just sit there and shoot us over a ticket, and we will help you find the information. They have a ton of information available. It is not easily accessible. Unless you are familiar with that brand, I can say in most cases. I'll show you one at the very, very end of all this here. Before I start taking questions, I'll pop it up on the screen, and you'll see what I mean. And it'll be on a 17 Jaguar, F-Pace. But anyhow, mostly the reason for some of these systems having missing information is that they're actually found within the factory scan tools, and you'll see it under there as guided fault diagnostics and routines. Lots of manufacturers do that. They don't lead you into the service information. What they do is they guide you to get to the tests that you want. We have to start Volkswagen and Audi because nearly every year, make, model, we can perform a monitor generation in the service bay. I hear Chris back there right now. He's gritting his teeth, and I'm saying that carefully. Nearly every year, make, model. For the most part, we can do this using a factory Otis tool when it's there and available to us under guided function tests. There are always catches with everything, but this is, for the most part, we can do almost everything that's in there. So for the rest of us out there, the way that we perform the tests is manually performing basic settings, which I just realized my screen may not be in the right spot here, but I'll get you to where we want to go. Year to year, we could spend a complete hour just listing them out. If I was to sit there and try to make you a list of every one of the monitor generations, they had books on these. There was numerous things. It really depends on what you find in service information. Don't take a manual that you see online somewhere out there unless you know for sure that it's specific to that vehicle and that's what you want to, that's what you choose to use. Don't take it to heart. If you're on one right now and you're sitting there doing 130 to test an O2 sensor for a readiness monitor generation, on the very next year it may not be 130, it might be 31. Okay, so just look at that service information and follow it through. If you're not sure, I'm going to look at this here for the aftermarket guys. Up here in all data, just sit here and type right up on the top, basic settings. When you type in basic settings in here, you'll see it down here with manufacturer scan tool. This is where you want to go. Do you have a manufacturer scan tool? If you don't, it doesn't matter. This is where they hide the information. It's much more easily accessible. I'm going to tell you that the key to all this is reading between the pictures. What you'll see here, I highlighted for you. Select diagnostic function 4, basic setting. This means nothing to me. Go to 060. This is a throttle body calibration. But I wanted you to see how it will be set up in there for you, though, in the aftermarket, so that you would understand the information is there. It just may not be as easy to find. Again, I say it's there on most vehicles. So I already mentioned this over here. You'll also note that in that previous slide over here, it says to press the Q button when done, right back here at the end. That Q button doesn't mean anything more. On your scan tool, it might be something complimentary. It might say the OK button. It might say the Go button, the Next button. Whatever the case is, each one might be displayed differently, but you can still use that information to move on with. This is a typical basic settings chart that you'll see come up. Depending on what's there, it'll give you what each one of the values are for every column that you'll see. Most of these are going to come out there. They'll have 4 bars that go across, and I'll show you that in a second. If it's not in the table format that we just saw there, it'll also be in zeros and ones. The binary display provides the same test data, just in computer jargon, but we have ways that we can look at that as well. Some UDS vehicles and newer newer vehicles, I should say, run the monitors as a complete process. They start from the beginning and go straight through to the very end. Yes, the tool has all the bells and whistles, so I'm going to show it to you. So this is our tool. When we're in here, if we're on our, and we wanted to do basic settings for a Volkswagen Audi, we would come right here where it says, this is where we perform basic settings. Control unit functions. Now, that is for doing it where we have presets. We have basic settings that are already set up in there for you. You don't need to know if it was number 31 or 130. It's already there for you. This throttle valve adaptation is 060 or is it a 098? It's one of them, but you don't have to worry about that because we have it pre-programmed in there for you. So on the next slide too, you'll see, but we have all the individual monitors already set up in here for you. I think that's an awesome feature. If by chance you decide that there's something that you want to do, if you want to do a repair verification and it's not in that list, going through your service information or contacting us for the service information, we can go in there and we can do manual entry. In manual entry, we have a different screen here where we're going to show basic settings here, and this is where we can enter them in manually as it's suggested. So let's say that we wanted to do our basic setting 064. We don't know what that is. Doesn't mean that we know what that is, but it's in our service information, and that's what led us there. This is where we would go here to actually manually enter it, and then we can begin the process. So moving out of Volkswagen, let's move into Jaguar Land Rover readiness information. I have to preface with Jaguar. There are certain monitors that will seem like they are the most difficult to run. There is documentation. There are TSBs. If you're having one and it's really giving you a nightmare of a time, spend time reading. The more you read on them, and I say this because that comprehensive component monitor I mentioned before, where it doesn't complete, that is a key item that you'll need in order to get your way through there. They included for us in here an EVAP service test. It doesn't do anything towards the completing of the monitor on paper. I always suggest if you have one and you don't have it, where your EVAP monitor is not complete, do not be afraid. Press that service test. You can certainly attempt to get something to run. Porsche, they really haven't. They gave us an evaporative emissions leak test. On our tool, it shows up as a short test. The short test, it may or may not run it in readiness monitor generation. Even the VW Cayenne has no option for it. So a lot of guys will say, well, that's Volkswagen. I can, I'm sure it has something like that. No. And by the way, the customer got a great deal on that one. So moving on to BMW Mini, we have a chance on these to possibly have monitor generation. Again, this is suggested by us. We have had success here and there. If you decide that you want to go in there and you want to run those service tests, certain things may go to completion for you. Again, the reason why I say to you that you never want to overlook it. Use those service tests and go for it. So again, it's not written service procedure, but if you want to do it, these are two of the ways here. This is the readiness monitor generation on ISTA. Just showing what's available there. I'll have to look at my big screen here when I'm trying to show you this. Reading out readiness codes is over here. To our next slide. The secondary error system is right here. This is where we would actually begin to perform our tests in there. So we would go in here, we would go into our fault pattern troubleshooting service functions, and it's there for us as readiness monitor generation. I think I have one more. Yep, there we are. This is our version of it, reading readiness codes. We can go right in there. This is our CARB status. This is where you can look for all the individual ones. I apologize for rubbing my nose, by the way, but I think a gnat just flew up in there. Not that that needed to be told for the webinar, but if you see me rubbing my nose, I apologize. So secondary error system monitoring. This is where we would go in here, and this is what we have up here on our tests. So as we activate our secondary air pump, we can watch to see what our oxygen sensors are doing there. Do they go peg clean? Both before and after the CAT. Key information. And again, BMW, we also have the diagnostic module for the tank leaks. Again, this is BMW or Mini. It doesn't make a difference there. I believe it's available in both of them. I did not have enough time to get my hands on both. That's the hard part. But there's notes in here for you as well. On our tool, we always make sure that we try to include a little bit of notes in there from some of the service information. Normal operating range is going to be between 15 to 85%. Notes on the fuel tank level. See it here? We always try to add in little bits of information in there for you so that you know what you might encounter when you're in there. And let's say you have a test that just simply won't run. Read the information. It's there for a reason. Mercedes-Benz, no readiness monitor generation there either. Some functional tests on the emission system bidirectionally. The experts say it will not run the monitor. I'm going to tell you again, run the tests. You will be surprised at how often what I think that does is that it's like almost like a jump start. It's like a kick start to get certain things running. You may have a test that does not want to run simply because it might not like outside ambient air temperature. If you force the test to run, it may overlook this. And as you run that test and then you start driving down the road, boom, all of a sudden the monitor is done. There's no pain in performing a test to try to get this done. Volvo, nothing. They have test plans that are in there with similar conditions that they'll tell you in here. We do have test plans that will run a similar model to conditions for a monitor to set, but it will not expedite the monitor without a complete drive cycle. On these cars, just make sure you check for a little bit of dirt in the canister vent. EVAP specifically. Let's go over some of the reasons that monitors don't run, and there's a huge list, and I'm only going to give you a piece of it there, but ECT, our oxygen sensor, slow response, but no code in there for slow response. Brake switch inputs, battery voltage, power steering switch inputs. If you've ever had a Nissan and you have AC not working, you know that power steering switch input could be the reason if you've ever encountered that. If not, call us. But power steering switch input there, that's a load input. If that's there going on and off, it certainly will not run the monitor. It's thinking, hey, I told this guy to go straight down the road on that highway at 45 miles an hour, and yeah, that didn't help us any. Clutch pedal inputs on automatic transmission vehicles. Subaru. Think Subaru there. Subaru had that problem there. They used to have a little clutch pedal input there. We used to see it up in the Northeast where we get some corrosion. Those clutch pedal inputs there, it would wear away. So you'd go in there, you look at your scan data, and you see, hey, the clutch is not depressed on an automatic vehicle. But that would prevent the monitors from running. Incorrect refrigerant charge. Just like power steering switch inputs there, if you have an incorrect refrigerant charge and your AC decides to come on and off because you have no choice but to have the defogger on and you're driving down the road, and that compressor's kicking on and off like crazy, you're not going to run the monitor. Fuel tank pressure skewed, GM, right away, that's the first thing you should think of. Where the fuel tank pressure sensor gets slightly skewed. It's not 1.5, it's now at 1.8 volts. Normal, open to atmosphere, it's at 1.8 volts. The monitor is not going to run properly. Skewed intake air temperature sensors, ambient temperature sensors, parking brake switch. I'll show you where that one comes into play in a little while too, but parking brake switch. If you can do readiness monitor generation and they're telling you to put on your parking brake switch and you haven't paid attention to the fact that you're not really getting a parking brake switch input, it's not going to run. Fuel level sender. We all have that one customer out there who's still driving around that vehicle and knows exactly how many miles he gets per tank. If the fuel level sender is no good, it may not run a monitor. And of course, you get into the slightly southeasterly wind when the moon is waning on a rainy autumn evening. But the list keeps on going on and on. Sometimes there's certain things in the data stream that jump out at us. Other times, not so much. So you have to spend a little bit of time really researching. So I'm going to give you one more little case study here. It was an obscure one. This is one that came in here recently for a vehicle that would not set ready. Let's see. Come on forward that slide. There we go. All right. So it was a 2013 Chevy Suburban 5.3. The symptoms, and I just copied and pasted this essentially from what we get on that ticket. The CAT and EVAP monitors will not go ready. It had previous fault codes in there, a P015D for bank 2 sensor 1 oxygen sensor slow response, and a U0073. I will show you what those were, but they replaced both upstream oxygen sensors due to a failing inspection. 400 miles on the vehicle over a 2-week period, and the CAT and EVAP would not come up. Really tried real hard to get these monitors to run. The 15D was because of the oxygen sensors that they had on there. The U0073 was a small handheld scan tool that they were trying to sit there and monitor driving down the road with for drive cycles. Keep that in mind. I'm making note of it in here. I did not make a slide for it, but I will tell you, sometimes the cheaper the handheld scan tool, be it coming from a tool supply store that happens to have very cheap tools, if you happen to have that plugged in there and you're driving down the road, and may also prevent the monitors from running. In this case here, it was setting a communication code, U0073. Right now, no active codes in the vehicle, and only the CAT and EVAP monitors were showing incomplete. So I decided I was going to remote into the customer scan tool and take a little look as to what he has going on there. At the time that he was in there, again, this is something that we do here at IBS 360. We prefer our scan tool. It's something that we're very, very comfortable with. But most of us out there have been out in the bays. We've been out there in the field. We know what everybody uses. So in this case here, he happened to have a Snap-on hooked up. So I logged into his Snap-on for him. This is the first screen that I came across. Well, I shouldn't say the first screen that I came across. After looking through other information, this is one of the screens that I came across, and it caught my eye. And what caught my eye specifically here was one data PID. I'm sure you see it already, and it's staring at you. But how often would you say that or say that you reference that PID, that Map Performance Test 1 PID? If you didn't see it, I'll go back real quick. Right here, that malfunction PID. What is it? What is that information? What is it going to do for me, and how would I do any kind of testing with it? It doesn't really stand out, right? The snapshot of that screen that you're seeing was only at the moment that I wanted you to that I wanted to capture it. I just wanted to try to catch it when it was up on the screen. So don't think for a second that that malfunction was there the entire time. The tech missed it. I could have missed it just as easily. It would only flash on there for a brief second and then go back over to OK. So unless you were really scanning through all the data with a fine-tooth comb, you'd absolutely miss that. Now, I'm not going to bore you with explaining what it actually took to find a proper explanation from that for that performance test. I can tell you that the information was very difficult to find, but it did end up coming up with it. The map test 1 is a correlation type of algorithm that looks between the map sensor against the throttle position. It comes up with it runs an algorithm. It says map versus throttle position. It doesn't seem to make sense. Whether the throttle position is open and we haven't depleted the lower pressure in the intake manifold, is the pressure starting to rise? Whatever the case may be, it doesn't like it. Map test 2 that you also see in that previous slide is for map to mass airflow. Makes sense, right? It makes sense that they're looking at the throttle versus map, and then they're looking at the mass airflow sensor versus map. It's a good way to sit there and come up with a correlation. But what could it possibly see wrong, right? In that slide, and I'll go back again, everything here looked pretty good, right? We had 17% load. We had 9.7 inches of mercury in the showing as our data PID. Our mass airflow sensor, this was a 5.3 liter. We have 5.38 grams per second. Our throttle position sensor is at 8%. Nothing really crazy, right? And these are all the items that are involved. So what did it actually see bad? Well, that's where we've got to put on our thinking caps, right? We have to try to figure out what's actually going on here. So I started asking some questions. I inquired about the mileage of the vehicle, 160,000 plus miles. Looks like it's a well-maintained car, certainly an everyday driver. And I went right to suggesting to clean the throttle plates. Again, if it was a mass airflow sensor or a map test performance 2, I would say, let's take a look at our mass airflow sensor and see what that has going on with map. I didn't think it would be map because why did we not have failing in both map test 1 and map test 2? I only see one that says map test 1 is a failure. So the easiest thing to do, and because it takes 5 minutes, is let's go in there and clean the throttle plates and see what happens. We clean the throttle plates. This is what I start to see. My map test performance now is showing okay. See it here? Look at my TPS, 4% and 4%. Right? My mass airflow sensor, grams per second, 5.49. I want to tell you that this is the exact same RPM. It was exactly 740 RPM. This truck was rock solid. It would get to 740 RPM, 549 RPM was the rock solid number. It was the exact same as the grams per second that I showed on here, and I thought that was pretty interesting that it sat almost exactly the same. But either which way, both on the screen cap that I captured, which you see I had cut it down a little bit for you, but also on the new version of the screen cap, where after the cleaning of the throttle body, we had already made a difference. So if we look at it very, very closely, the tech had told me that when he cleaned the throttle body, there was barely anything there, that it seemed like just a normal amount of, just a slight carbon buildup in there. There was no idle complaints. There was no low RPM issues. So what is it that we actually did? The vehicle, he took it, by the way, for a 10-minute test drive, called back in there and said, well, cat monitor completed. Can't believe it. But if we really looked at that data closely, again, I just showed you some of it there. That throttle position sensor percentage was the exact same as the engine speed, at the exact same engine speed, had halved, right? It was 8% before, now it's 4%. Clearly, somewhere in that algorithm, it was looking for that throttle position to be a little bit too high. Nothing else changed. The compensation didn't change. Nothing else changed there, but it was able to run the monitor just simply by cleaning the throttle plates on there. So don't overlook certain things, and make sure you're really looking on a vehicle that everything looks okay. Look for the things that you don't know, and that should be across the board. Anytime at all you're looking at a set of service information and you're looking at a data pit that you have never seen before, go and do the research. Find out what that actually is, and even if it takes a while, make it your nighttime homework or whatever it is, but go do the research and try to find out what it is. It took me a while to try to figure that out, especially working during the day, to figure out what that service information really was telling me. And once I found that what that map test performance was, I had a game plan. And we executed the game plan and everything worked out well. So make sure also, and I wrote this in here, save good screenshots from every vehicle that you possibly can. If it's in there for an oil change and you have a moment to plug in a scan tool because whatever, you have just a moment to go ahead and do it, take good screenshots. Get known good data. Make sure you have your engine RPM in there as a good baseline, just like I did on this one. But always make sure you make a little library for yourself. And then when you look at that library, if you don't know a PID, if there's something in there that you don't understand, go and do the research for it. You will become better at everything that you do. So, drive cycles. Here's my rules. Service information, service information, service information. Then call me. When you call me, I'll go ahead and send you over correct service information that you couldn't find for over an hour because the darn fangled company that you get your service information from is always moving it, so and so. Then you finish the prescribed drive cycle in under 30 minutes, deliver the vehicle to a happy customer. Those are my rules. It's that simple. You go ahead and you want to do drive cycles, this is what you do. Follow your service information. Drive cycles need to be treated like a medicine prescribed by a doctor. It's very, very easy to forget that it's a computer. It's reading zeros and ones on the decision-making side. It does not care whether or not there was something that was out on the road that's caused you to slow down, that you saw the police officer off to the side of the road and you realized, hey, I better let up off this throttle because I really am going 8 miles an hour over the speed limit. It doesn't care. It's a computer. So don't think that there's going to be leniency when you're trying to run a drive cycle, especially a tight spec drive cycle. It's a computer. It has no other rationality for you to offer. It doesn't care. Or that you had to tap on the brake because you decided that you wanted to have cruise control on because that was easier to keep it that way at 55 miles an hour. If it doesn't say put on cruise, don't put on cruise. Just be steady on the throttle. Leads us to following rules of the road. Scan tool is considered a handheld electronics device in some states. I'm pointing that out to you. I won in court. That's all I got to say. It took a while, but I won in court. Anyhow, if readiness monitoring generation is not available for the vehicle that you're working on, you need to play it smart. Let the customer see the procedure that you're going to have to run. I say that, and I'll show you a picture of one in a moment, but make the customer aware of it. Say, hey, Mr. Jones, this is what I have to do. I have to run this monitor on your vehicle. And I know this is not really what you're here for, but I'm saying this to you as shop owners, technicians, service advisors, whomever you are out there. This is important. There's nothing wrong with scheduling a time for a customer to leave a vehicle for a drive cycle. If that customer is sitting there as a waiter and it's 11:30 in the morning, and you know that by the time you get out there to go drive that drive cycle, it's now lunch hour. What are your chances of running a vehicle steadily at 55 miles an hour for 10 minutes? Think about that Nissan one for a moment there. What are your chances of being able to run that out there on the road during lunch hour where everybody's rushing back and forth there and not having something, come in the way of what you're trying to do? So sometimes the mere sight of a printed drive-out cycle is enough to have the customer concede and understand that there's billable time here, right? And you have to have billable time for this. This is not something that should be included in the normal repair. Charge for it. You'll see when you're starting to go in there and you're doing your research, make sure that you look at them and you say, hey, look at this drive cycle. This is not something I can, do within 5 minutes of me just driving down the road and coming back. Some of them are. Some of them are quick and easy. Some of them are 15 minutes long. But when you read the criteria, can you achieve that 15 minutes perfectly without ever touching a brake pedal, without ever having to accelerate too quickly? Do you have a highway that you can hop onto? But anyhow, make every attempt possible, though, to perform the drive cycle at a time when the Sasquatch watchers are not out and about. And if you don't know who they are, that's them right there. They stop, they see that Sasquatch. You're the guy way back here at the end of this line. But over here, this guy up here at the front of the line, he saw the Sasquatch. Now, by the time you get up there, that Sasquatch is gone, and I'm convinced of that because I guarantee that there was one up there on the Staten Island Expressway. But I just wanted to make that known to you, though. Just make sure that if you're trying to attempt to do a drive cycle, and I won't go through all the drive cycles, but if you're trying to do one, make sure that you really do the research on the information, make your customer aware of it, the service advisor aware of it. You need to get paid for it. So a tip from a friend. Speaking to Eric O'Braka from South Main Auto, we were having a conversation about this webinar, as we normally do, good friends. And we ventured into a vehicle that he had just run a monitor on. But he said to me, I ran the cab monitor in the bay and I got it to pass for inspection. And I said, but a General Motors vehicle. And I'm just going to thank him now for contributing into the next tidbit of information there that we have. So the vehicle that he had referenced, and this is not the vehicle that he fixed, but the vehicle that he referenced there was a older vehicle as well. First, a 2003 Buick Century 3.1. It was brought to him for monitors incomplete, needed inspection. Vehicle sat for some time. The battery went flat. The customer replaced the vehicle and then went out there and did a couple of drive cycle attempts. After attempting the drive cycle on the road and following the procedure, Eric came back into the shop and showed it still is incomplete. Visual in his inspection there, when he threw it up in the air just to give it a once-over because he had heard some noises from sitting for a while, he noticed that that there looked like there was an aftermarket catalytic converter replaced in there not too long ago. So he decided for whatever reason to go inside there, and then since he couldn't get the cab monitor to run, he said, well, I'm going to look up the code criteria for the PO420. So I'll share that with you. The engine's been running for more than 10 minutes. The coolant temperature is above 158 degrees. The barometric pressure has to be above 75 kPa. It's in closed loop. You guys can get through the rest of the information there as we go along. But that's not all it said. It said warm the catalyst, fully open the hood, transmission in park, set the parking brake, and press and hold the service brake. Remember before I mentioned the parking brake. Again, it gets important, right? If that parking brake switch doesn't work, what you're about to see won't work either. So each time the engine is started, the diagnostic can run up to 18 times. After the 10-minute run time, before the diagnostic runs the first time, the engine must be run an additional 5 minutes between 1,500 and 2,500 RPM. The engine speed must be there for at least within the same key cycle for up to about a minute. To activate the diagnostic, return to idle and put the vehicle in drive. Okay, so you've activated the diagnostic. Now you're putting it in drive. Are we driving somewhere? No. Test the catalyst. The transmission is in drive or neutral. Within 60 seconds of putting it in drive, the air-fuel ratio will go up to below 14.1 for 6 seconds, and then it may go above 15.3 for up to 8 seconds. What they're doing is the oxygen storage capacity test. That's what they're doing right there in the bay. That's their test. And what it really was is actually ran the monitors. And he was as surprised as I was when he told me. But it runs the monitor on the vehicle, and that's in the service information. So sometimes we have to look even a little bit deeper. Again, we're here to help you with that. But if you're going in there and you're looking at certain things, sometimes look up the code criteria. Pay a little bit of attention to the code criteria and say, this is what I need to concentrate on. I can actually run this in the bay. Even if this was just a test and it didn't run the monitor, I would come back with a result and say, hey, this cab monitor just flagged something in mode 6 here for saying that it's marginal. This is where I need to spend my time. So before you go too crazy, always research. And that's the point of all this. But the best part of this was, though, that he's been able to run it on many other vehicles, including a 2013 Chevy Cruze, which is the specific car that we were talking about in the beginning. And in the service information made no mention of it, but he was having a hard time with this one and it wouldn't work. And he ran that exact same procedure. And sure enough, the oxygen storage capacity test still runs. So 2013 Chevy Cruze. So I decided to include that in here because it's not in service information. I thought that was a great tip. So if you're stuck with that, make sure that you sit there and you do make sure you do your research and try to find as much as you can. And don't be afraid to sit there and look at something and say, wow, look at this little test in here. I don't know what that actually does, but I can't break anything, right? Because it's in there, it's in service information, and they're saying that it's okay to do. Go for it. Like I said, sometimes you just need to. Drive cycle is not just for running a monitor. It's also for repair verification. I can't stress that enough there. If you've replaced a part and you want to make sure that the part is an actual repair, run the drive cycle. But if you can, run it twice. If it's not too crazy, if it's something, especially with readiness monitor generation, where we can generate that monitor and you can run it a couple of times, do it. It's worth it. That way you know that the customer is not going to come back in there and you're not going to have a comeback on the vehicle, and that the actual test is not just complete, but passed. That you've actually sat there and you run this and everything is good to go. So if you ever need a talking point in your shop, again, I'm not here to help you with your shop, but I am. I want you to hang this next slide up in your shop and just wait for it. This is the slide. If you leave this just sitting there in your office, you're going to get a lot of questions. Everyone's going to want to know, what am I actually looking at here? That's a drive cycle. That drive cycle happens to be for a 2006 Sonata 3.3. And of course, the procedure itself seems like it's ludicrous at first, but if it's done properly, it takes about 30 minutes. I say dyno time. If you have a loaded dyno, a dyno that has the ability to put a load on there, it is so worth it. When you have one that looks like this, to try to run that. 5 minutes here, 2 minutes and 30 seconds at 50 miles an hour, 90 seconds back in idle, in drive. I mean, look at this criteria, right? Then there's even a vehicle shut-off, ignition switch shut-off down here for an extra minute. Back up again, jumping right up again to highway speed. If you're doing this, I mean, I don't know about where you're from, but if I was to attempt to do that out there in New York, and the cops were sitting there on the side of the road and they saw me keep on pulling over, then taking off and going up to 50 miles an hour and then pulling over and then driving again 50 miles an hour, I have a feeling that I'd probably get pulled over. So anyway, just a reminder here, completed monitor does not mean passed. A monitor set to ready does not mean that it's passed. When you're looking at the readiness screen, just make sure you keep that in mind. I don't want you to think that just because you've run a monitor or that it shows ready, that that the repair has been done. You want to use it as a means to verify your repair. I know I repeat a couple of things here, but those are I think are extremely important parts. But always use mode 6 also if you want to see if the test is actually truly passed, right? Even though it says complete up there, go back, look at your mode 6 data. If you see something that's marginal and it pops up on there and you're looking at it and the minimum and maximum there and it's 0 to 10 and your number is 9.3, you're marginal. You have the ability to fail on the very next cycle, and that customer is going to come back to you. So in conclusion to all this, I just want to remind you that this was really just a beginner's class. If you are looking for advanced methods and testing classes, you will want to wait for part 2 with Chris Martino. And he's probably over there right now going, no, because I totally made this up. It's not really in there yet. It is something, though, that we want to be able to provide this to you later on, hopefully as a class. We're going to go into a little bit deeper OBD theory and operation and, be able to provide you with more there. But just in case he does do the class, though, I heard that he's going to teach us what the meaning of life is. So that concludes everything here on my end. Chris, anything else that you want to go over? And do I have a Chris? Let's do this here and stop this. We have to stop our screen share. I have lost the other person along with me. So what I'll do is I'll pop in here. Oh, there you are, but no sound, sir. Let me see if we can get some sound in here. I'm afraid I do not have sound for you. Okay, Chris, listen, that's okay. Now you can't complain about having to do the new class. But I'll take care of the rest. I'll hop in here and let me take a look at some of these questions that are available. I know that there was probably a few of them. Yes, this drive cycle is insane. There are still old cars around here in California. Do we have dynos that can be used for dry cycle testing? Yes, Chad, they do. And actually, in New York, we had it in there. It was part of the old inspection station. They had a loaded dyno. It actually made it available for us. Says, just lost voice. I hope I didn't lose my voice somewhere in there. Okay, audio is still good for some people. Apologize. I'd like to know if there's any way you can get a handout for the LabScope Basics 101 webinar. I'm sure Chris can follow up on that. Dave Hobbs, could you please explain the search in the all data titled Basic Settings? Okay, so the search that I did, let me go back to that slide here. This is for Dave Hobbs. Let me get back to the slide he's looking for.